Hello everyone. Today's video is for discussing similarity of documents, and this discussion is a part of subject web intelligence and big data. So we will be discussing how documents or how we can find out similar documents and how this can be done by finding out Jaccard similarity and whether it is possible to compare two different documents without checking each and every word in those documents. So we'll be seeing all these things in today's video. Okay, so before moving on, let us see where these similarity of documents can be useful. So first you may be trying to find out similar web pages. So this can be used for two things. If two web pages are almost same to each other, then they may be mirroring of websites. You may also be interested in categorizing the web pages. So for that you may find out pages which have similar words, and based on that you can define the category of different web pages. We may also be interested in finding say users which have similar tastes for some movies, or they have similar choices in purchasing products. All these things can be used to build up recommender systems. We may also be interested in finding images of related things. So if we are uh, having a category, say food, and inside food, if we are having a category of cold drinks, then we may also get some results which are close enough to cold drink. So all these things might be useful uh, when we are trying to find out similar documents or similar sets. So what do these similarity algorithms do? They mostly try to find out items that are very similar, or probably just find out somewhat similar documents. So we will be talking about the second parameter here, which is somewhat similar. So what we do, we try to find out documents which may be similar to each other. We don't say they are very similar, but we say they may be somewhat similar. And then if we find these documents, we say that these are our candidate documents, and then we may go ahead for detailed similarity analysis. So this is what we will be going through today. So how do we compare documents if we have to find whether a pair of documents are similar? We might run through both the documents um, and compare word by word. So if these are the two documents, D1 and D2, we may be going through these documents word by word and comparing to see whether they are similar. But if there are some words here in the beginning, or if this paragraph is similar to the last paragraph here, it might be difficult for us to find out the similarity. So rather than performing character by character similarity, let us see if we can have any other method to find out somewhat similar documents. And moreover, this technique of character by character matching may be computationally expensive and may require a huge amount of time. We have already discussed a few of examples in the previous slide. So here are a few more examples for finding similarity over the web. First, we may be trying to finding similar web pages to find out which are the mirror sites. We may be interested in finding a news article which is present at various different sites and we may try to cluster the articles which belong to the same category. And those clustered articles may be then further analyzed or may be used for research purposes. One more application here is trying to find plagiarism, whether a content is taken as it is from somewhere else without citing it and without the permission. So that is plagiarism, and it should not be entertained. So we try to find out plagiarism and try to remove it because it is not a good practice. So a few techniques, these are a few techniques which we will be going through and using so that we find the similar documents. So first is called as shingling, where we try to convert documents, emails, and whatever is the type of input in a form of a set. So all these inputs are converted to sets. Next is min hashing, where we convert these large sets. Now, once we have sets, we try to convert these large sets into short signatures while we are preserving the similarity and not changing the document meaning. And finally, we apply locality sensitive hashing so that we can find out similar pair of documents. So this is how it works. A document is converted into set. So first the document is converted into set, and then a smaller representation is obtained by applying min hashing technique, and these representations are called as signatures. And then these signatures are used by locality sensitive hashing to obtain which documents are similar to each other. So for example, if we find that document D1, D2 and say D3, D5, these are the candidate pairs which are similar, then we might be checking only document 1 and 2. That is, we will be comparing only D1, D2 and D3 with D5. So if this would have not been applied, then our comparison would have been D1 to all the other documents which are present, D2 to all the other documents which are present, D3 with all the other documents. So we would be finding a n by n matrix if there are n documents, right? So this is now reduced if we have candidate pairs. We will only do these two comparisons and avoiding huge number of comparisons which were originally required. Okay, so let us now in detail discuss what do we mean by all these. So first is to convert a document into set form. So how is that done? So we form a K shingle for a document, and this K represent the size of the uh, uh, elements inside the shingle set. Okay, so if we consider an example here, the K value is given as 2, and let us consider this as the given document. So what we have to do, we have to consider a sequence of K characters that appear in the document, and this has to be considered in a sequence. Okay, so if this is my document and K is 2, what will be the shingle set? So this is combining two characters. Why 2? Because K is 2. So combining two characters to form a single element. Next, and this is done sequentially. So we have to move ahead going from left to right in the document. Next will be BC. Next will be CD. Next is AB. So if you see, AB is already present in this set, and if we are writing inside a set, if it is already included, we do not rewrite it in the shingle set. So we move ahead and we get BD. So these four elements will be uh, two shingle set for this document. So if there is an application that wants us to also point out what are the number or the counts of these elements being present in the document, you can also maintain a count that okay, this AB is present twice in the document, or this sequence AB is present twice in the document. So now we have discussed how a document only having characters can be obtained here. Here it is not necessary that there are characters. These characters can also be words. So you may be combining different words to form a single element. Okay, so that is called as to find the shingle for a document. So we will see this how we can find or represent a document as a shingle or as a set. Prior to that, how to obtain min hashing, we might be constructing data as a sparse matrix. We can find Jaccard similarity measure and constructing the signatures. So let us now discuss how we can represent documents as a set or using this shingles which we have discussed. So here, since it is about documents, we will take consecutive words and group them as a single object or element. So if these are the four documents which are present, so let us consider this as an example. We have these four documents and we are trying to find k equals 1 shingle. So if it is 1, we are not actually grouping any item, we are considering them as single items. So here for document 1, I will have I am Sam. So I am Sam. Again, Sam is already there in this set. I is already there. Am is already there. So nothing new is included here. I is already there. Do is included here. Not like green eggs. Not like green eggs. So all these are included as single terms here since k is 1. Okay, so now, and if you see it is represented as union, so it indicates that we only have to write any particular element only once, and we will not be writing any element twice in this set. So this is how we obtain the value of k equals 1 as a shingle. Now let us see if we have to get k equals 2 as the set. So what will be there in this set? We now have to combine two consecutive words. So for document 1, the first set will be I am. Next set will be am Sam. Going to the second document, this is Sam I. Next word is I am. So I am is already there, and since this is a union set, we do not write it again. So go to the third document. The next object should be I do. Next object combining the next two is do not. Again combine the next two, it is not like. And this is how we will be including two consecutive words together for all the 4 documents. Here is the answer. You can have a look at the answer. So similarly, as k is 2, we can have value of k as 3, value of k as 4, or in any number of consecutive words can be grouped together, and this is based on the application which you are trying to cater to. So if you want to look for sentences that are similar, then might be the value of k is higher, and if you want to look for exact match, then you might keep the k value low. Okay, now let us discuss what is Jaccard similarity. So this is a similarity measure used to find the similarity between two sets. So what is it given by? So Jaccard similarity of two sets is the size of their intersection divided by the size of their union. So if you see, you have to consider the size, or basically the number of elements which are there in that set. So if C1 and C2 are two sets, then the similarity between these two sets is given by intersection between these two and the number of items which are present in this intersection set divided by the union set. Okay, so now let us consider an example. This is the first set and this is the second set, and this will be the Jaccard similarity formula for A and B. So let us try to find out what will be the values here. So first of all, let us write down the elements which will be present in A intersection B. So all elements which are present in both, this is 0, 2 and 5. And we take this to find the number in this set. So there are 3 elements in this set, and at the bottom we need to denominator, we need to have union of these two sets. So we have 0, 1, 2, 3, 5, 6, 7, 9. Okay, and then we count the number of elements in this. So this is 8, and we get the answer as 0.375. So the Jaccard similarity between these two sets is given by 0.375. Next, Jaccard similarity can also be applied with clusters. So if there are say 4 sets given to us, so there are 4 sets C1, C2, C3, C4, and we say that C1 represents some action movies, C2 is representing comedy movies, C3 is representing documentaries, and C4 is representing horror movies. And then we built up sets A and B, and these are nothing but the clustered sets. And these clustered sets, so this A clustered set comprises of C1 and C3 from here, and B cluster comprises of C1, C2, C3 and C4. Now we can also apply Jaccard similarity to these clusters. So if we have to apply it to cluster, we will write Jaccard similarity of A, which is a cluster, and B, which is a cluster. So it has two sets C1 and C3, whereas B has these 4 sets. How many sets are there? 2. And how many sets are here? It is 4. So we get it as 0.5. So the Jaccard similarity between these clusters A and B is given by 0.5. Okay, so now let us discuss all what we have discussed up till now. We know how to convert a document into set, and we know how to compute Jaccard similarity. Now we will combine these two and try to find out the Jaccard similarity between two documents which are represented as sets. So here are the same four documents which we have seen here, and these are represented in the form of sets. So every document I am Sam, so these are represented in the form of sets having k equals to 2. And now we are trying to find out the Jaccard similarity between document D1 and D2. So to find out this similarity, we need to find out what is the intersection, divide it by the union. And now here we have sets as individual elements. So if you see both these documents, this I am is a common set. So there is one intersection, divide by total number of sets in the union would be I am Sam, and Sam I. So this is 3. So 0.333 approximately is the Jaccard similarity value for document 1 and 2. Now let us find what will be the similarity between document 1 and document 3. Now if you see here, there are no elements which are same. So there is no intersection between these documents. So this is 0. This is directly 0, or if you write it divide by 9, it becomes a 0 here. Next, let us find the similarity between D1 and D4. So for D1 and D4, there is only one set that is similar, or that would come under intersection, and there are in the union total 8 sets. So this will be 0.125. Similarly, you can find the similarity for D2, D3, D3, D4, this is D2, D4 and D3, D4. And you may compute and then verify your answers. This comes to be 0. This will be 2 by 7, giving us 0.286. This will be 3 by 11, giving 0.273. Okay, now let us see how we can find Jaccard similarity for columns. So if the documents are represented as columns, and if we are finding similarity between these columns, so let us say this column 1 is representing our first document and column 2 is representing the second document, and we are trying to find out the similarity between two. So if you have to find the similarity between columns, your numerator, which is an intersection, it says that it should agree in all the columns. So only if you have 1 in all the columns, you have to count them. And the denominator is a union, and in that case you have to consider the number of rows in which at least one of the column it contains 1. Okay, so let us see here. So if you see this one and this one, so both the columns have 1. and only in that case you say it agrees in all the columns, that is it contains 1 and you have to count them. So here we have 2. Next, denominator is all the rows in which there is at least a 1 in either of the column. So if you see here, there is a 1 here, there is a 1 here. These two will in any way satisfy the condition, and here is a 1. So if you count these are 5. So 2 by 5 gives us 4 as the Jaccard similarity for these two columns. For example, we now add a row 0 0. So for column C1 it is 0 and for column 2 it is 0. In that case it is not satisfying the numerator condition and there will be no change in the numerator, right? So there will be no change in the numerator because there is it is not agreeing in all the columns, right? Let us see whether it is satisfying the denominator condition. So if you see here, the number of rows you are counting where at least one of the column should contain 1. So if you see here, none of the column contains 1. So again, there is no change in the numerator, in the denominator also. So whatever may be the columns, and even if there are n number of 0 0 rows, those rows will not be considered here while finding the Jaccard similarity. I hope this is understood. Next, what are signatures? We are trying to hash each column to a smaller signature value. So if these documents may be very long and we are trying to reduce that document into smaller signatures. So these signatures should satisfy a property such that they fit in the main memory for each column, and when you try to find out the similarity for two documents, then these should be same as the similarity of the signatures of these two documents. So it should not be changing the similarity between the other columns. So basically there can be 4 type of rows when you consider a column representation: 1 1, 1 0, 0 1 or 0 0. So if there are two columns, these are the only possible values. And this row where both are 1 1, say mark it with a hash because these are the ones which we are considering. And this D row is never considered. So the similarity between C1, C2, this is given by A divided by A plus B plus C. Next we'll see how to perform min hashing, and we will try to find out the signature of documents. So first we have to perform permutation of the rows, and this is done randomly. So if there is a matrix given to us, then we will row wise try to do the permutation. Maybe the first row becomes the last row, this row becomes the first row, and so on. But we do not perform this permutation in reality. It is imagined to be permuted and then the computations are performed. So we will see this in the next slide, how this is performed, how this is done, and how we can find signatures. Okay, next we need to define the hash function, and this hash function is basically equal to the number of the first, so this is in the permuted order, first row in which the column has 1. This will be clear once we do an example. Next, we can use several independent hash functions to create a single signature. The more number of functions or independent hash functions we use, we get a better representation of the document and we get a good signature. Let us consider this as the input matrix, and let me just call these columns as C1, C2, C3 and C4. And next we said that we have to perform permutation. So to perform permutation, we are keeping this input matrix as it is, that is the columns or the rows are not changed uh, in the memory, but we will consider them to be permuted in this order. So this is a permutation that we are uh, assigning it. So if you see, this is 1, that is we need to start, and this is our first row. If we use this permutation, this is our first row. And to find the signature matrix, so this is our signature matrix. This will also be of the size uh, or these will also contain the number of columns which are here. So this will be of the size 4. And again we'll write 1, 2, 3, 4 here. And to fill this signature matrix, we start with this 1 because this is where we are starting from. This is a random permutation that is considered. Now, if you see, there is 1 present at columns C2 and C4. So at 2 and 4, what will we write? We have to write this value, which is 1. Next, we consider the second row. So now this is our second row according to this permutation, and this will be the row under consideration. Now if you see, it has 1 under C1 and C3. So for 1 and 3, it has 1, and what will we write? We will write this number 2 because this is the second time we could write in this matrix. So corresponding to this permutation, this is the signature that is obtained. Now let us try and apply another permutation and obtain a new signature, and we keep this input matrix same. So as we said, we can apply many hash functions to get a better signature. So we'll apply many permutations to get a good signature. So let us consider this as the second permutation. Where will we start from? We start from this row since 1 is present here. So this is 1, and we start from here. This is the row. Again, the signature matrix will have 4 elements corresponding to 1, 2, 3, 4. 1 is present at C2 and C4, that is second and the fourth. So at second and the fourth, I will be writing this number 1. So 1 or the first row is done according to the new permutation. Now this is the second row that needs to be considered. So this is the second row, and in this row we have 1 at C1 and C4. So where is 1? At 1 and 4. So at 1 we will write 2, And if you see at 4, there is already a value present in the signature. So we have already computed a signature, so we'll make no change to the existing signature value. And then we go ahead to the third. Why are we moving ahead? Since we haven't completed the signature yet. So this continues until the signature is completely built. Now this is the third row which we are considering. C is present, 1 is present at 2 and 4. Now if you see 2 and 4 are already written, so we will make no change at 2 and 4. Next, we will go to 4, and if you see 1 is present at 1 and 3. So it is present at 1 and 3. 1, if you see, there is already a signature present, so we will not make any change. But for 3, what will we write? We will write this number, which is 4. So 2141 will be the signature obtained for this permutation number 2. Let us go ahead and discuss one more permutation. So this is, say, the third permutation. And here if you see, 1 is here itself. So we will start with this row. 1 is present in C1 and C3. In the signature matrix, we will have 1 at 1 and 3. Next, go to second. So this is the second row which we are processing. 1 is present at 2 and 4. So it is present at 2 and 4. We will be writing at 2 and 4. What will we write? We'll write 2. And this is the signature matrix for the third permutation. So combining all these together, so this is the first permutation, second and third that we have applied on this matrix, and we have obtained these signatures corresponding to the different permutations, and this will be our new signature matrix which represents our input. So now this input is reduced to this size of 3 by 3. Okay, but it is since there are only 3 permutations, it is not necessary that it is a very good representative of the input matrix. So when to apply min hashing? It is basically applied when you have large number of documents of very huge size, and then you apply say hundreds and thousands of permutations to get a signature matrix. Then it will be more effective and efficient way of comparison. So what is similarity of signatures? It is basically the fraction of hash functions in which they are agreeing. So let us see here. So what are similarity for columns? So if you try to find similarity of columns here, and what are the similarity of signatures? So if you see, there is a slight deviation here. So this is because the data is small and we have created a smaller signature. If there is a huge data and a correspondingly bigger signature, then these deviations might be low. So let us try to understand this. So if we are trying to find out the Jaccard similarity of column 1 and say, let us find it for column 3. So this is the first column and this is the third column. So we are having a look at this and this column. So you have to first find out the intersecting values. So for C1 and C3, the number of intersects and union of these. So if you see, this 1 and 1 is same, this 1 and 1 is same, this 1 and 1 is same. So these are column Jaccard similarity as we have discussed. This is 3. and union would take up the number of rows where there is at least a 1 present. So this is 1, 2, 3, and there is a 1 here. So this is 4. And if you see other rows, this is 0, 0, 0, 0, 0, 0. So these are not taken into consideration for column Jaccard similarity, and we get this value as 70.75, and this is the similarity between column 1 and column 3. Okay, now these columns, or rather documents, are here represented again as C1, C2, C3 and C4. Let us see what will be their similarities in terms of signatures. So now we are trying to find out Jaccard similarity for signatures of C1 and C3. So what is the intersection and what is the union? So now we will be considering these two columns from the signature matrix. So this 2 and 2 are same, 1 and 1 is same. So we have 2 intersection out of how many total? It is 3. So we get this as 0.67, and this is the similarity between the signature matrices. You can go ahead and try to solve for column similarity between column 2 and 4, and then their signature similarity, similarity between 1, 2, 1, 3, and verify whether you get these same answers. The next topic of discussion would be LSH. Happy learning.